our final lesson of this unit, that's lesson 9.5, now takes us into the realm of doing calculus with vector valued functions. So, position, velocity, acceleration. Yes, you've seen these things before. The position vector, well, there's your x of t, comma y of t. And this, of course, gives the location of the object. The velocity vector, v of t, right? Well, the velocity is just a derivative of position. Remember all those things from way back? The acceleration vector, yeah, you got it. The second derivative. And what about this thing called speed? Well, we know from physics it's the magnitude, or the absolute value of velocity. And so in this case, it's just the velocity components squared and then the square root of it. So once again, speed is just the magnitude of velocity. Distance traveled, integral from a to b of the square root of x prime of t, y prime of t, dt. And if I'm thinking something's at rest, then yes, the velocity components must be actually both equal to 0. So, with those things in mind, let's try example number 1. So given a position vector, this is the x component, this is the y component, for a particle moving along the xy plane, I'd like you to find the following. So part A says graph the path of the particle. Notice this is the xy coordinate axis, so I'm going to actually use our graphing calculator to help us out. This time, the mode I'd like us to use is the parametric mode, because you have that parameter t. If I press y equals 2, then you've got your two parameters, x1t, y1t. So x1 is just 3t squared. And then t cubed minus 3t squared plus 4. And if I ask you to graph with the window, my t min is 0, my t max is actually only 2. Each step could be 0.1. My x minimum on the graph seems to be like -2 all the way to 12, the scale being 1 unit. -2 is the minimum y. The maximum y seems to be 7. A scale of 1 unit. Let's graph. And there you have it. Seems like it starts at 4 and all the way ends at 12 down here. Whee! Okay. Whee! And it stops. Okay. So, how do we calculate the velocity vector? Well, the velocity vector is just the derivative. So, what's the derivative of 3t squared? You got it, 6t. What's the derivative of t cubed minus 3t squared plus 4? You got it, 3t squared minus 6t. And then we're going to evaluate this at time equals to 1, so just plug in 1, and the velocity vector is 6 for the x component, 3 minus 6, -3 for the y component, at the value of t equals to 1. The speed, though, well, that's just the magnitude, so the speed will be equal to the magnitude. I'm going to take the components and square them and take the square root. 36 plus 9 is 45, so root 45 or 3 root 5. That's the speed at time t equals to 1. Distance traveled will then be the integral from 0 to 3 of the two speed or velocity components, so 6t all squared plus 3t minus, or 3t squared minus 6t all squared, and of course the dt. Can't do this algebraically, so we'll use the graphing calculator. Let's go ahead and do FNINT. I'm looking at the square root of 6t all squared plus bracket 3t squared minus 6t close bracket squared. I'm going to close the square root bracket, then put comma t, comma 0, comma 3. And let's see what number I get. I hope you get the same thing, 28.583. So that's the distance traveled. Times when the particle's at rest. Well, at rest means that the velocity components both have to be equal to 0. Where's my velocity vector again? It's right here. So therefore, 6t has to be equal 0. And also 3t squared minus 6t equals to 0. So for the x component, t must be 0. For the y component here, I factor out 3t, and I see that t equals to 0 and t equals to 2. But the only one that works is the one that's shared by both, so therefore t equals 0 is my final answer. That's the only time when the particle is at rest. Acceleration, that's the second derivative, so looking at the velocity, I better take the derivative again. So the derivative of 6t is 6, derivative of 3t squared is 6t, derivative of negative 6t is negative 6. There you have it. If I want you to evaluate it at 2, then yes, you just plug in 2, and notice the x component is still 6, and now also the y component is also 6. And if I ask you for direction, once again, hope you remember that from last day. The direction of the particle means I need to find the x and y components first. So I'm going to ask you to find the position vector, which is s. And we have to look back up at the top. So s of 1 just becomes 3. 1 minus 3 is negative 2, plus 4 is 2. So therefore the angle theta is just the arctangent of the y over x. And we can calculate that. Inverse tangent of 2 divided by 3. That's of course 0.588. Okay. I asked you for t equals to 2, so I'll let you try that as an exercise. I will hopefully have you do it, but I know many of you are lazy, so you probably just copy my answer right out anyway. Fair enough, but I hope you can do it yourself, because that's what a good student would do. Are you a good student? Thanks for being honest. Okay, turn the page. One last example, and we're done for today. Example number 2. This time, notice you have a particle, and it's moving along the xy plane. I give you the acceleration vector this time, and I gave you some other information. When t equals 0, the velocity vector is this, it's 0, 3. And the position vector s at 0 is 2 root 2 over 2. Your job is to find the velocity vector, then the position vector, then the speed, then the time when it's at rest, the direction it's traveling, and last but not least, part F, which is the distance traveled. Can you do this on your own? I sincerely hope you can. If you can't, I'll show you at least the first one, part A, but the rest, it's up to you. Okay? The velocity vector. How do I find velocity from the acceleration? You guessed it, the antiderivative. So if negative 2 cos t is the x component, the antiderivative of that would be negative 2 sine t. Don't forget though, you have your plus c. Now I'm just going to call this c1 because we're going to have another constant from the y component. Negative 3 sine t, its antiderivative is 3 cosine t, and I'll put down plus c2. How do we find C1, C2? Well, that's why I gave you this information. When t equals 0. So when t equals to 0 and 3, notice that when I plug in 0 for sine of 0, 0. 0 times whatever is still 0, so you're left with C1. Over here, cosine of 0, however, is 1, so 3 plus C2 equals to that component. And so, comparing as we do, the 0 and C1, the 3 and 3 plus C2, what you would have found was C1 equals 0, and C2 also equals 0. So therefore, our velocity vector is just equal to negative 2 sine t, comma 3 cos t. And then if I want you to find the actual vector at pi over 4, now we can plug in pi over 4. We know that that's 2 times sine of pi over 4. That's root 2 over 2 times 2, which is 2. And then over here, 3 over root 2, I believe. Okay? Alright. The rest is up to you. Go and try B, C, D, E, and F. I'm going to make you wait extra long for the answer. You like no noise? By the way, if you're waiting for the answer, why don't you try it yourself? That's what I did ask you to do. Try yourself. The x component, the antiderivative of negative 2 sine t, 2 cos t plus some other constant, I'll call it C3. Antiderivative of 3 cos t is negative 3 sine t plus some other constant, I'll call it C4. Using your initial value here of 2 root 2 at 0. So cos 0 is 1, so 2 plus C3. Sine 0, 0, C4. So therefore here C3 must equal 0. C4 must equal root 2 over 2. And therefore our component S of t must be 2 cosine of t, the negative 3 sine of t, plus root 2 over 2. And evaluating at pi over 4, cos pi over 4, that's just root 2 over 2, so that's just root 2. And then sine of pi over 4 is root 2 over 2, negative root 3, plus that's negative, oops, so what is that? Negative 3 root 2s over 2, plus root 2 over 2, that's just negative 2 over root 2. Okay. Negative 2 root 2 over 2, which is just negative root 2. Is that right? Yeah. Speed. Velocity's magnitude, so using this information here to help us out. Negative root 2 all squared plus 3 over root 2 all squared. That's just what, 2 plus 9 over 2. That's just what, 13 over 2. So I'll just leave it as root 13 over 2. That's the exact answer. They like that on the AP exam. times when the particle's at rest. That means the velocity must equal to 0 to both components. So the x component equals to 0, and the y component equals to 0. In this case, t equals 0. In this case, t equals to pi over 2, 3 pi over 2, and so on. Are they ever the same? Never, so therefore the particle is never at rest. Okay, can't find the same t values for both the x and y components. A shame. Direction of the particle when t equals to pi over 4. Well, that means I have to look up here, so theta equals to inverse tangent of inverse tangent of I have a feeling I made a mistake somewhere. By the way, this should have been just negative root 2 over root 2. Do you see my mistake anywhere? Do you see my mistake anywhere? I think I made it up here. Oh snap. And now my computer's frozen. Snafu. Yikes. Is it actually frozen? Maybe it's time to quit. Alright, spot my mistake. Come to class. Let me know. And I'll reward you with a special treat. How about that? Do you like treats? My daughter likes treats. So does my son.